So this is the 10 integrals set number 2. So number 11. So we can do this integral x over x squared minus 3 square root. And if you get a problem like that, the typical way to do that is the u sub. So we can do u equal x squared minus 3. Also you can do this problem as a trig sub. So x equal, you can say square root 3 secant theta, but we are not going to do any of them. We can do the other method, that is the 4 formula trick. So we can use the 4 formula trick. So what is that? Look at the inside function. It is x squared minus 3. So the derivative of that is 2x. So that means 2 is missing. So what we do, we put 1/2. We do 2x and then x squared minus 3 square root dx. We can simply write this one as 1/2 2x. If you bring this to the top, it is x squared minus 3 to the negative 1/2. Now what the formula 4 formula trick says, when you have the derivative, when you have a function and its derivative as a function and that's a derivative, when you have the function and the derivative, you can simply treat the function as just as x. So just treat this as x. So that means so you can write this one as 1/2 we have here. So if you just treat this one as x, you need to add 1. So it is x squared minus 3, add 1 means become 1/2 divided by 1/2. That's the 4 formula trick, and this simplifies very well. So this and that get cancelled, so you're gonna get the answer as x squared minus 3 square root and plus c. Don't forget that. Good. Now let's add the plus c here as well. Good. Number 12. Number 12 is this problem. It is 2x minus 3 x plus 1 square root dx. We're going to do this problem in 2 different ways, as 2 different problems. So the first method is you can do this as integration by parts problem. And for the integration by parts, you need to take u equal the polynomial part 2x minus 3 and then dv as the root function, and then what we can do, we're gonna take the derivative, so it's du equal 2 dx and integrate v equal, so this is just a 4 formula trick again. You can just, because the derivative of that one is just 1, so simply treat this as x. So that means it's gonna be 2/3 x plus 1 3/2. Okay, so that means we can substitute that to the integration by parts formula, so which is uv minus v du, the integral. So and if you plug in here, you're gonna get 2/3 uv, just multiply the 2, so it is 2x minus 3 and then x plus 1 3/2 minus v du. V is 2/3 x plus 1 3/2. Du is 2 dx. So this is very easy to integrate. I'm going to write it here. So you're going to get 2/3 2x minus 3 x plus 1 3/2 minus you're going to get 4/3 and then you just integrate, so that you're going to get negative 2/5 x plus 1 5/2 plus c. Okay, and you can simplify a little bit. Okay, so if you want to simplify, you're going to get 2/3 2x minus 3 x plus 1 3/2. This is 8/15 x plus 1 5/2 plus c. So that's the final answer. Okay, let's do this as another problem, as a different problem. So other technique is just the u sub. So if we have 2x minus 3 x plus 1 square root this is x plus 1 square root. So we have x plus 1 square root dx. So what's the other method is we're going to use the u sub. So we're going to pick u equal the inside function. So u equal x plus 1, and then what we're going to do, because you want to solve for x, so we're going to solve for x. If we solve for x, it's become u minus 1, and also we need the derivative. Derivative is du equal dx. So we're going to transform the problem. So what's going to happen, x is u minus 1, so that means it's going to be 2u minus 5 after simplify, and then x plus 1 is u, so it's a u to the 1/2 du. Now what do we do? Just distribute. Once you distribute, you're going to get 2u to the 3/2 minus 5u 1/2, and then du. Now you can see that it's a very simple integral in terms of u. So that means you're going to get 2 times, you add 1, become 5/2, so it becomes 2/5 u to the 5/2 minus 5, again add 1, so it becomes 2/3 u to the 3/2 plus c. Now what do? You substitute for u, so it is 4/5 u equal x plus 1 5/2 minus 10/3 u equal again x plus 1 3/2 plus c. So you can see that they look slightly different, but you can show that once you simplify, you can show that they are the same. Okay, so you can show that they are the same after simplification. Okay, with some constants. Okay, let's do the next problem. So number 14. So 14 is another actually this integral x 3/2 natural log x dx. So when you look at the problem, you can see that this is an integration by parts problem. So what we can do, we have u equal ln x. That's the trick. You have to pick the log function as u. If you try to do the other way, it's going to be more complicated. So the rest of the function goes to the dv. So this is du equal 1 over x dx. This is v. So it is 2/5 x 5/2. Very good. We have everything we need. So we're gonna go substitute for the integral parts formula. So it's gonna be uv. Uv means you're gonna multiply. So it is 2/5 x 5/2 natural log x minus v du. V is 2/5 x 5/2 du is 1 over x dx. Now what's the next step is we're going to simplify. So we're going to leave this one 5/2 x to the 2/5 2/5 x to the 5/2 ln x minus 2/5. You can take it out. If you simplify inside, it's going to be x to the 3/2 again dx. Now what we can do, we can integrate that part. So you're going to get 2/5 x to the 5/2 natural log x 2/5, and when you integrate that one, you get another 2/5 x to the 5/2 plus c, and you can simplify this a little. Okay, you can combine these two. Good. So the next example, example number 15. So example number 15 is a integration by parts problem. So let's see 2x plus 1 over with repeated factors. So what are you going to do when you have repeated factors? Dx. So if you have repeated factors, you can write the form has a slightly different version. So what's the form going to look like? 2x plus 1 over x plus 2 x minus 1 squared. This is identical to, we first write the linear factor x plus 2. So if you have powers, you write powers all the way up to the last one, and then everyone take the form of the smallest one. So x minus, that means the linear, that means everyone has the linear form. We explained that in a previous video. So you can look at that if you want. Okay, so that's the format. There are no cx plus d. I mean, you can, but that's just a waste of time because you'll get extra unknowns for that. Okay, now what we do, this usual thing, we're gonna multiply by the common denominator on the left side. So then you're gonna get all the other missing terms. So that's the missing term of the denominator. Here the missing term, there are two missing terms. One is x minus 1, one is x plus 2, and there is a one missing term here, x plus 2. You can do the hiding method, but you know, not really needed. This is just one extra line. Now what we can do, we're going to use the hybrid method. What's the hybrid method? We can do substitution as much as you can, and then we do the coefficient. That's the kind of trick. So this is going to make it much faster. So what you can do, you're gonna, let's say you want to find a, try to make the other two terms 0. That means you need to plug in x equal -2. Once you do that, the other two terms get 0. Okay, so that means if you plug in -2, you're going to get -3 here equal a times, if you plug in -2, you're going to get -3 squared, and you can see that all the other two terms are 0. So that's the trick. You get a right there. So a is -3 over 9. That means -1/3. And then let's do one more sub. X equal, let's say you want to find b. Actually, you can see that you can find b, but you can find c directly. So if you want to find c, you can make the other two terms 0. That means x equal 1. You're going to plug in x equal 1. When you play x equal 1, you're going to get 3 equal, this is 0. That's a 0. And from the c, you're going to get c times 3. So it says that c equal 1. Okay, now what we can do, we're going to go for the largest coefficient. So we're going to do the coefficient of x squared. That's the x squared is the largest term. So we have to go with the largest term. So if you go for the largest term, you can see that there are no x squared here. You get an x squared term when you expand. It is a times x squared. So you don't want to expand it. Just think about how you get it. Because when you multiply these two, you get x squared, but coefficient is going to be a. And then for the other one, when you expand this, you can see that x you multiply. So coefficient is going to be b. So this says that b is -a. But a we already know, so 1/3. So you can see that that's the fastest way to do it. It doesn't take much time. So let's go back to the integral and plug in those three numbers. So that means once you plug in the numbers and distribute, this is what you get. So you're gonna get the integral 2x plus 1 over x plus 2 x minus 1 squared dx equal -1/3. That's the a. So then x plus 2 dx, and then b was 1. So it is b was 1/3. So it's 1/3. You can say 1 over x minus 1 dx, and the c was 1. So that means it is 1 over x minus 1 square dx. You can see that these are very easy to integrate. So this is 1/3 natural log x plus 2, because we don't know whether this is positive, and then 1/3 natural log x minus 1, we don't know if it's positive. And this is 1 over x squared type of problem, and that's a constant. That means you can ignore that. So it's like 1 over x squared. That means -1 over x. Okay, so that means in this case it's going to be negative, not 1 over x, but 1 over x minus 1, because that's what you have. So it is 1 over x minus 1 plus c. So that's the answer. Good. Let's go to number 16. Number 16 is, let's do like a tan squared x dx. So one of the trick is we try to see whether you can combine, you can kind of transform this to something known using some trigonometric identity. Actually, you can see that yes, you can do that here. So tan squared x is simply equals to secant squared x minus 1. So you can see that this is very easy to integrate now. So this is simply tan x minus x plus c. So very simple. Number 17. Let's do this problem. So 1 over x ln x square root dx. So if you look at this problem, you can see that inside function is ln x, and you can see the derivative of ln x is 1 over x. That's already there, so that means that's the way to do it. So that means you're going to pick u equal ln x, and then right after you do that, du become 1 over x dx. That's there, that's 1 over x dx is there, dx over 1 over x. Okay, so that means you can write this problem as you can say 1 over, I'm just gonna write this extra line just to help you to understand how I do this problem. So like that, we take the derivative part. Now you can see this is simply 1 over u square root du. That's it. So this one we normally do it, you're gonna bring u to the top. You can skip this step if you want, and so this is gonna be simply you add 1 divided by that plus c. This is 2 times e square root u. So in this case 2 times ln x square root plus c. Very good. Number 18. So let's do number 18. Let's look at the problem first. So this is tan inverse x dx. So when you see tan inverse, we know that this is a integration by parts problem. Okay, so that's the trick. So that means we always need to pick that part as the u. So that means u equal tan inverse x. So that's the trick. So you can look at the review and where I explain why we need to do that. And the rest of the part gonna be dv. So that means if you take the derivative, this is 1 plus x squared dx. That's something you remember. And the v equal x. So we have everything we need. So let's plug in. So that means uv, that means x tan inverse x minus v du. V means x over 1 plus x squared dx. So you can see that this is a very simple integral. You can use a 4 formula trick here, because the bottom function, the derivative of the bottom function is 2x, so that you can generate on the top. So that means if you rewrite this one as 1/2 2x 1 plus x squared, things are easy because that's the derivative of the bottom function. So by the 4 formula trick, we can write x tan inverse x equal minus natural log. You know the bottom function is positive, so you don't need the parenthesis. You just put a bracket there because that's positive, always positive. So that's it. Number 18, not 19. So let's do number 19. This problem we can do sine cube theta d theta. So from the trig integrals, we know that when you have a odd sine power or odd cosine power, what do? You use the other function. What's the other function? Means u equal cosine theta. So that's the trick. So that means, so that's from the theory. So this is the derivative is sine theta d theta. That means you know that you need to isolate one of the sine term for that, and you need to write the rest of the terms using cosine. So that's the trick. You isolate one sine and then write the rest of the terms using cosine. So that means we can do this one as sine squared theta, and then we isolate one sine theta for the derivative, and then what we can do is we can write the first function as 1 minus cosine squared theta from the trigonometric identity, and then also we can put a negative sign here, put the negative sine theta d theta. So that's the kind of trick we can do. Now we can substitute, so it becomes negative 1 minus u squared. This whole thing is simply du. So that means this is very easy integral. So if you integrate, you're gonna get negative, you're gonna get u minus u3 over 3 plus c, and then if you bring this sign inside and substitute, you're gonna get u3 over 3 minus u plus c, and then now what you can do, you can substitute. So once you substitute, you're gonna be cosine 3 theta over 3 minus cosine theta plus c. Make sure that you bring back to the original variable. The last one. So what's the last one is this one. So this is like one kind of common integral that you see pretty much everywhere. So this is like used in physics, d theta. So what we can do, we can use the 4 formula trick here. So what the formula trick says, that if you see the function and if you see the derivative, you can simply create this one as like e to the x. So that means the answer is e to the x means e to the sine theta plus c. That's it. There's nothing else to do, because you only notice that it's a function that's derivative. Also, if you want, you can do this problem picking u equals sine theta, but you don't want to do that if you notice this.